Okay, hello students. My name is Asif Ameer, and I'm an undergraduate from University of Colombo right now. I'm done with my first year, going on with my second year. So I'm also conducting combined maths class for A-level students English medium. So today's video we are going to discuss the 2014 advanced level question in combined maths, specifically the 11th question. Now the 11th question, the top part is from polynomials, remainder theorem and factor theorem, and the down part is from quadratics. This will be a somewhat of a long video, 20 minutes odds. And the complete answer will be given, how I derived the answer and everything. So stay tuned with the video until it ends. So read the question. 11th one, A part, they are telling you, let A be a real number and let fx equals 3x to the power 3 plus 5x squared plus ax minus 1. It is given that 3x minus 1 is a factor of fx. So let's write down the question. So it's 2014 A levels, part B, Pure Maths part B, question number 11, A part. They are telling A is a real number. They are also telling that let fx equals to 3x to the power 3 plus 5x to the power 2 plus ax minus 1. It is given that 3x minus 1 is a factor of fx. They are telling that 3x minus 1 is a factor of fx. Now, when they are telling that 3x minus 1 is a factor, what we can conclude from this part is that the limiting value of 3x minus 1 is 1 over 3, obviously. So, factor theorem, by factor theorem, we can say that f 1 over 3 is equals to 0. The limiting value of this, if you substitute into this, should be equals to 0. So let's substitute. So f1 over 3, which is equals to 0, is equals to 3. Wherever you find x, put 1 over 3 to the power 3 plus 5, 1 over 3 to the power 2 plus a 1 over 3 minus 1. 3 over 3 times 3 times 3 plus 5 over 3 into 2 plus a over 3 minus 1. You are going to have here 0, here 0. 3 into 3 is 1 over 9 plus 5 over 9 plus a over 3. We can put this minus 1 to the other side. So I will put here 1. Then 1 equals to 5 plus 1, 6 over 9 plus a over 3. 2, 3. So you can have here cross multiply. 3 equals 2 plus a, and a equals to 3 minus 2 equals 1. So a equals 1. Okay, first part of the question done. Then they are asking express fx in the form of 3x minus 1 x plus k. So you know the new fx value is actually wherever you have 1, wherever you have a, you can put 1. 3x to the power 3 plus 5x to the power 2 plus x minus 1. Okay. Now normally to find this, you have to divide this fx by 3x minus 1, then you can find the other factor. Now normally you can use any theory you want, which is long division, or else you can use the comparing coefficient method. But personally, I like the long division, so I will use the long division method. So I think I have enough space here. I do it here. 3x to the power 3 plus 5x squared plus x minus 1. You divide it by 3x minus 1. Okay. So within 3x you have x to the power 2. So 3x into this, 3x to the power 3 minus x to the power 2. 5 plus 1 is 6x squared plus 6 plus x minus 1. Here 2x, 6x to the power 2 minus 2x. Then this will be 2 plus 1, 3x minus 1 plus 1. So this one you can write it as x squared plus 2x plus 1 as x plus 1 to the power 2. So now fx, which was originally equal to 3x to the power 3 plus 5x to the power 2 plus x minus 1, is actually equals to 3x minus 1 times x plus 1 to the power 2. This is fx. Now this is in the form of 3x minus 1 x plus k to the power 2. So you can say this is in the form, you have to write this sentence, in given in the question. What happened here? This is in the form. This is in the form given in the question. When k is equals to 1. Okay. Okay. Then the next part of the question they are asking, by writing 3x minus 1 in the above expression in the form b times x plus 1 plus c, where b and c are constants, find the remainder when fx is divided by x plus 1 to the power 3. Okay, so to do this, what you need to do is they are asking 3x minus 1 in terms of x plus 1. Okay, for example, this you can use they are asking 3x minus 1 to be written in the form b times x plus 1 plus c. 3x minus 1 equals bx plus b plus c. Okay, so you can compare coefficients. If you compare coefficients, you can say x, left hand side it's 3, right hand side it's b, so b equals to 3. Then x to the power 0, you can say b plus c equals minus 1, b is 3, 3 plus c is minus 1, c equals minus 4. So you can write 3x minus 1, instead of this you can write 3 times x plus 1 minus 4. Obviously 3x plus 3 minus 4 is 3x minus 1. Okay. Once this part is done, now fx, what you can do is, instead of 3x minus 1, instead of this, you can see here you have this part, so you can put this part into this equation. So wherever you have 3x minus 1, you can put this, so put with the bracket, definitely put the bracket, okay, times x plus 1. Why the bracket? Because this part is multiplied by this part, which means wherever you put this, you should definitely put the bracket. Now you can open the bracket, multiply this by this, you will get 3 times x plus 1 to the power 3 minus 4 times x plus 1 to the power 2 fx. Okay. Now what are they asking you? They are asking find the remainder when fx is divided by x plus 1. So you can see this is the dividend. Then you can see this is the divisor. Then this would be the quotient, which means this expression here will be the remainder. So you can see when fx is divided by x plus 1 to the power 3, the remainder is minus 4x plus 1 to the power 2. Okay. Then this part is completed. So this part is giving you the remainder theorem, factor theorem, the polynomial part. Then the B part we are going to go. So before we start the B part, if you are enjoying this video, definitely like, put a comment, and definitely subscribe. The contact number is in the description. So if you want to have any more doubts clarified, or if you want to join the physical law online class, all you have to do is drop a WhatsApp text. I will definitely reply. The B part, let A, B, and C is an element of real number, and they are telling specifically AC is not equal to 0. Now this part is non-negotiable. AC is not equal to 0 is given in the question itself. They are asking you show that 0 is not a root of the equation ax to the power 2 plus bx plus c equals 0. They are asking you to show that 0 is not a root. What do you mean by root? Simple terms, if you put the root for the value of x in the equation, you should get 0. That's a simple idea. Okay. Now, they are telling to show that 0 is not the root. Whenever they are asking you not, I will assume the opposite. So let's assume 0 is a root of the equation. Okay. Then we can get x equals 0. When x equals 0, you can say ax to the power 2 is a 0 to the power 2 plus b 0 plus c equals 0. So 0 into anything is 0. So here 0, here 0, c equals 0. Now when C equals 0, you should be able to get AC equals to 0. You have to write something. So if C equals 0, then AC equals to 0. If C equals 0, definitely AC would be equal to 0. But we know that AC is not equal to 0 because this is given in the question. AC can't be 0, which means that which means A can't be 0 and C can't be 0. Both of them can't be 0. You put an and here. A can't be, no, this is a symbol of and. You don't have to put this symbol, you can just put and. A can't be 0, C can't be 0. Now, A can't be 0 is obvious because in a quadratic A definitely can't be 0. So even we can put this symbol here because this is a quadratic. Quadratic, the first leading coefficient can't be 0. That is satisfied. But we also have that C can't be 0. It's not a O, it's an and, which means both should be satisfied. So now we are getting a contradiction because logically, according to the question, C can't be 0. But the moment you assume that 0 is the root, C is getting to be 0, which means one of them is wrong. Since this part is the question, which means our initial assumption is wrong. Since there is a contradiction, our assumption is wrong. What is the assumption? Our assumption that 0 is a root is wrong. So if it is wrong, what is the correct one? Therefore, we can conclude that therefore 0 is not a root of the equation ax squared plus bx plus c equals 0. The perfect answer. Okay. Then the next part, let alpha and beta be the roots of this equation. Okay. So ax squared plus bx plus c equals 0, alpha and beta. So first of all, since the roots can't be 0, alpha is not equal to 0, beta is not equal to 0. Okay. Then alpha plus beta is equals to minus b over a. It won't be equal to 0 because 0 plus it's not 0. No. Alpha beta still that's not equal to 0 is equals to c over a. Okay. Then they are telling you that AC, they are also giving something called as lambda, and they are telling you let lambda equals to alpha over beta. I'll box this part. Lambda equals to alpha over beta. Box all three value. So that now in your exam, don't go to box these. Okay, they will think that is the final answer. I'm just boxing this so it will be easier for me to spot it. So lambda equals alpha or beta. They are asking us to show that AC lambda plus 1 squared equals to b squared lambda. So I'm going to take from the LHS. So AC, wherever I have lambda, I can put alpha over beta plus 1 square. This is AC lambda plus, so alpha plus beta over beta square. This is AC, this one squared over beta squared. Now lambda alpha plus beta is actually minus b over a, so I can say this is equals to AC b squared minus b over a whole thing squared. AC over beta squared, b squared over a squared. This part and this part cancel off. Okay. What is remaining is cb squared beta squared a. So I will put this b squared separately because in the final answer there is a b squared. Then I will put this c part here, okay, and a part right below it, okay, and I will put this 1 over beta squared separately like this. So I have three parts of the this. Now b squared won't be changing, but we know c over a is alpha over beta, so I can say b squared here, this is alpha over beta divided by beta squared. Then beta 1 here and beta 1 here cancel off. Here you have beta squared alpha, b squared beta alpha over beta. You have b squared alpha over beta is lambda, so you have lambda. We got right hand side. We start from left hand side, we got right hand side, which means this part is proved. Okay. Next. Next they are asking let P Q and R is real number. They are telling PR is not equal to 0. Okay. Also tell then you have an equation px squared plus qx plus r equals 0. Let gamma and delta be the roots of this. They are telling now if gamma and delta are the root, gamma plus delta will be equals to minus q over p. Gamma delta is equals to r over p. Okay. And the next thing that you need to remember is that this is equals to this. This is equals to this. The next thing you need to remember is that now this looks very familiar to what we derived last time. Okay, very familiar. Basically the same thing in different symbols. And yeah, they are telling you that mu equals to gamma over delta. So since these two are equal by the previous pattern, by the previous pattern, okay, by the previous pattern you can say that they are telling AC. No? So the previous pattern is you got this. Yeah, you got this. So you can write it like this itself. uh, I will write it here because it's easier to see. AC lambda plus 1 whole thing squared equals b squared over lambda. By previous pattern this we can say that instead of AC you put the first letter P and R. Lambda plus 1 here, lambda instead of lambda you have delta. So delta plus, no sorry, instead of lambda you have mu. Mu plus 1 squared equals to q squared mu. Okay, we'll put this as equation 1 and put this as equation 2. Show that lambda equals mu or lambda equals 1 over mu holds if and only if ACQ squared equals PRB squared. Okay, now we'll divide the first equation by the second equation. So you will get AC lambda plus 1 over PR mu plus 1 whole thing squared equals B squared lambda over Q squared mu. Now if you cross multiply, you get ACQ squared lambda plus 1, okay, we'll get a mu here, equals to PR B squared lambda mu plus 1. Okay. Now they are giving you an if and only if statement. So if ACQ squared equals to PRB squared, this will happen if this part is equal to this part. If this part is equals to this part, then obviously this part must be equals to this part because here you have an equal sign. If these two equals only, these two, the whole thing would be equal. So if this part's equal, then you can say this equals to lambda mu plus 1 square. Now this is the logic here. Then this will be equal. Now you have to put this symbol, if and only if symbol. Mu lambda squared plus 1 plus 2 lambda equals lambda mu squared plus 1 plus 2 mu. Open bracket, mu squared lambda mu lambda squared mu plus 2 lambda mu squared plus lambda plus 2 lambda mu. 2 lambda mu cancel off. Take everything to one side. Put this plus this minus this minus this equals to 0. So I will take lambda mu out, lambda minus mu. Here from here lambda will come here, from here mu will come. Minus take lambda minus mu. So basically you are matching this and this together, which will give you here, and this one this together, this will give you this. It is that. Okay, so you now can take lambda minus mu out. This will be lambda mu minus 1 equals to 0. Now this is ACQ square equals PRB square. Okay. Now this, you can say this lambda minus mu equals 0 O, lambda mu minus 1 equals 0, lambda equals mu O, lambda equals 1 over mu. ACQ square equals PRB square. This is what we want. Okay. In other words, what we are reading is ACQ square equals PRB square if and only if lambda equals mu or lambda equals 1 over mu. You can write it the other way also. It works both way. Lambda equals mu or lambda equals 1 over mu if and only if ACQ square equals PRB square. Okay. And then they are giving you a new question. It is given that the roots of the equation kx squared minus 3k, 3x plus 2 equals 0, and 8x squared plus 6kx plus 1 equals 0 are in the same ratio. What is the ratio? Lambda equals mu, lambda equals 1 over mu. So if the roots are in the same ratio, what you can say is AC x squared is equals to PRB square. So if you put the letter, this will be A, this will be B, this will be C, P, Q, and R. A, C, Q square, P, R, B square. You will get 2 into, I'll put multiplication sign, k into 2 into k to the power 3, 6 into 6 equals 8 into 3 into 3. Minus 3 to the power 2 is actually plus, no, so we are not going to consider the minus. Then 3 cancel off with 6 becomes 2, 3 cancel off with 6 becomes 2, 2 2 is 8, so this cancel off with this. So k to the power 3 equals 1, which means k equals to 1. They are asking us to find the value of k, and we have successfully found the value of k. That's it. Okay, this question totally will give you 150 marks, which is very easy to obtain. Very easy question, one of the easiest quadratic question. Then this video basically has discussed everything that will come, and every aspect of the question, which means watching this video will give you 100% clarity as to what to expect in the paper. Okay, we will meet you once again with a new video with a new question. Until then, stay tuned with us.